Let's take a look at this logarithmic function here. So I'm not going to go through all the steps of graphing logs. Instead, what I'd rather do is talk about some of the big picture things to look for that are really going to help you to identify what's going on when it comes to multiple choice graphs and to identify which one is correct. So the first thing I want to talk about is a difference between exponential and logarithmic functions, but I'm going to jot down a little bit about both, even though they don't both apply to this particular problem. But let's go ahead and review in general. So when it comes to an exponential function, so what I'm talking about with an exponential function is a base exponential function where we have y equals some base to the x power. So I'm not talking about modified with transformation. So I'm not shifting this up or down, left or right. I'm not stretching it, just a base exponential function. One of the things that we should remember about a base exponential function is that it's always going to go through the ordered pair 0, 1. And this is not any sort of fancy rule. This just comes from the fact that anything raised to the 0 power is 1. So if you plug 0 in for x, you're going to get 1 for your y every time because anything to the 0 is 1. Now, because the logarithm is the inverse of the exponential, if we're talking about a logarithmic function of the form y equals log base b of x, then we can just flip-flop that ordered pair and say 1, 0 is on every logarithmic function. So those are two facts I want you to make sure you know, and they're really the same fact, just rewritten in two different ways. So making sure that you know that on every exponential graph that hasn't been transformed, the ordered pair 0, 1 is on it. And therefore, every logarithmic graph that hasn't been transformed will have 1, 0 on it. Now, for either exponentials or logs, the other piece that you can make sure you know is that if their base is larger than 1, then the graph is going to be increasing. And by increasing, I mean as you walk from left to right on the graph, you're walking uphill. And then the flip side of that is if the base is between 0 and 1, then your graph will be decreasing. This is true for both exponentials and for logs. And so by decreasing, we mean the opposite of increasing. As you're walking from left to right along the graph, you're going to be walking downhill. So, what are we trying to graph? Well, we're graphing a logarithm, so we know that the ordered pair 1, 0 should be on our graph. Our base is 1/2, so we should be decreasing. So for our graph, we should be going through the ordered pair 1, 0, and we should be decreasing. So as we look at our four multiple choice options, C doesn't go through 1, 0. B doesn't go through 1, 0. And D doesn't go through 1, 0. So really A is the only one that does. Now he is decreasing as well, so as you walk from left to right, you are in fact going downhill. So we can be very confident in our answer that A is the correct one.